Welcome to the Energy Summit. This next session is an overview of Cisco's ultra-reliable wireless backhaul product, brought to us by Leyn.
Right now, we're going to get into the Cisco Ultra Reliable Wireless Backhaul product, which was formerly Fluid Mesh, acquired by Cisco just about 2 years ago. And this product line, we're going to spend a little bit of time on before I get into the fun stuff of being able to share what some use cases are, which we'll hand over to the next portion of the presentation, which will be BATS. But first off, I want to kind of just broach the subject a little bit about wireless. And when you come from a Cisco perspective and you come from the different industries, there are a multitude of wireless solutions that can meet your technology needs. And you need to understand, what are you connecting? What's the best application? What are you connecting to? What use cases are? How do you deploy it? What's the CapEx and the OpEx? So you have a multitude of choices: Wi-Fi, 4G, 5G, LoRaWAN, WeSun, and each one of these has a very particular need or use case to fulfill. And so we take this approach of, let's understand from your customer or your as a customer perspective, what is the use case? What is the solution that you're trying to solve? And we may come at it from, this is a hybrid approach from 5G and Wi-Fi, or it may be just a LoRaWAN and some Wi-Fi. It could be the ultra reliable wireless backhaul and Wi-Fi. I mean, could be all of the above. And so it's really about making sure we understand what we're trying to accomplish. And if anybody, and I hear this all the time, everybody's waiting for 5G to come out and it's going to be the magic pill and it's going to solve every single problem in wireless in the world. That's a mistake. It is not going to solve every single problem that's out there in wireless. Nothing ever will. And because there are different use cases that are out there. Is it going to help a fair amount? Yes. Is it going to be cost effective to take a 5G solution and replace it, say, with a LoRaWAN solution? Or the other way around, replace the LoRaWAN with 5G? Probably not. So we really want to make sure we understand what your use cases are. And before we go into more and more, we want to sit down with everybody and make sure they understand where they're coming from. So what are the applications that you're dealing with? Do you have a need? This is, of course, wrapped around the ultra reliable wireless backhaul. We have an ultra low latency solution. It's very high performance. It's very reliable, easy to deploy. It's going to be something that the operators are going to want to use. And once they've tried it out, they get a better understanding. And there are various use cases that we have managed to put this solution into. And some of them, rail is where we kind of started off in the mobility application. We have fixed applications for point-to-point, multi-point, and mesh, and then we have what we call our mobility, which is fluidity, and that gives us connectivity in a rail. I mean, just to give you an example, a train can go down the track at 350 kilometers per hour, and we're going to maintain a connection. We have haul trucks and mines. We have connections at ports and terminals. I'm doing some testing with a field and down in the Permian Basin, and this field has connectivity to 8 wellheads and 2 trucks that are roaming within the operational area. And it's all connected with our fluidity network. So the fluidity doesn't care if it's fixed or if it's mobile. And then we get into, the backhaul side of it. When Cisco brought us on, we were called Fluid Mesh. But in reality, we're a backhaul solution. So they changed the name of us to Ultra Reliable Wireless Backhaul. We just happen to be a backhaul solution that's both fixed and mobile capability. And some of the things, we're the train to ground connectivity. We want to do connectivity in the oil fields or in the refineries or in processing plants. You've got a connection where you need to connect up. I literally just looked at one about 10 minutes ago for a customer up in Canada. And it's a terminal up in Canada. And they wanted to have connectivity for building to building. And they couldn't run the fiber. I shouldn't say they couldn't, but it was cost prohibitive. They couldn't dig the trench. They would, the permitting was ridiculous. And so we actually have a campaign right now called No Fiber, No Problem. And so when you think about the connectivity, if you think you need to run fiber, and it's just, you look at from this point to that point and you find out, I can't get there with this fiber cost effectively, let's do it with a wireless solution using the curb solution, as we call it. So LAN-to-LAN connectivity across buildings, backhaul for your SCADA sensors. the connectivity in ports and terminals. I've got a terminal. This happens to be a customer in Long Beach, one of my customers, and called Total Terminals. And we're connecting up the video cameras, the gate control systems, the RTGs, the cranes, the trucks on the ground. Everything is all hooked up with the curb solution. And so whether it's fixed or a mobile asset, it's all connected on the same network. And then we get into the mining, which I've mentioned, and we have different applications there. I'm not going to dwell on these things too much because I want to get into the meat of what we're really here about. And this is going to be seeing some exciting stuff coming up from BATS antenna here soon. But, you know, an idea, I mean, you can apply this to anything. We have connected roadways and education systems and municipalities. Virginia Department of Transportation, they use our system throughout the entire state to connect up their lighting controls, their signage systems, just the lights themselves on the highways and the streets, communication, video, all of this is connected up. So it doesn't matter to us where it's at. It's a matter of let's find out what that use case is and find the best solution for it. So one of the things that we can do with it is we can deliver your own network, very low latency, very reliable, high performance. And so when I say very reliable, it's an MPLS-based protocol. It's a proprietary protocol. So it's not a 802.11 or Wi-Fi. Of curb radio can only see a curb radio. And it's very low latency, sub 10 milliseconds without any tuning. You take it out of the box and it's going to be sub 10 milliseconds. If you need to achieve better, which I have seen and personally have been involved with, we're achieving sub 1 millisecond for many, many applications. It's one of the premier applications for anybody that's doing anything autonomously or teleremote, remote control solutions, just anything that's moving. And then it's a self-healing network with 5 nines reliability. I mentioned already we can go up to 350 kilometers per hour. And proven in the field day in and day out. We've actually tested it to 500 kilometers per hour. And it's an unlicensed spectrum. Currently today, it's in the Uni 1, 2, and 3 bands. Most everybody's using 1 and 3. It can go up to 500 megabits per second. We do have a new product we're introducing next month, which I can't quite show yet, but we will be showing here very soon for those who are going to Cisco Live. But I can tell you in this new product, we're going to be able to achieve 7.6 gigabits per second, and we'll go all the way up to Uni 8. So we'll have a lot more capability, and that product is coming soon. It's funny how, Louis had mentioned, the IoT OD, the operations dashboard. The new product, the curb solution, will be running on that dashboard. The current products do not, but the new generation will. So out of the box, every single product is a fixed architecture, whether it's point-to-point, point-to-multi-point, a mesh mode, or a mixed mode. And then with some licensing, it's a software-defined solution. We change the breed of the solution. We change its role. We tell it, we don't want you to be point-to-point anymore. We want you to be a mobility solution. So we change the software and we tell it to have a different purpose. So whether it's mining, train to ground, ports and terminals, factories and refineries, smart cities, anybody wants to see something fun and exciting, go look up Indy Autonomous Challenge and you'll see race cars driving autonomously around the Indianapolis Speedway connected up to 11 radios and around the track, going 150, 180 miles per hour. Matter of fact, we just broke the land speed record a few weeks ago, 193 miles per hour for an autonomous vehicle down in Florida. And this is all connected with the curb, formerly fluid mesh solution. And then, so the key technologies behind it, I mentioned the MPLS-based transmission protocol. We call it Prodigy 2.0. I've mentioned the fluidity. It's our proprietary fast roaming protocol for the vehicle to ground communications. We have a Titan proprietary fast failover solution. We use this in various ways, both on the mobility side, and we use it also on the fixed side. It allows us to achieve 0 millisecond connectivity as we roam from one radio to another on the mobility side, and then it allows us to have redundancy without human intervention for failover on the fixed side. And then we get into management of it. The curb solution, Cisco Ultra Reliable Wireless Backhaul. We have an FM monitor tool. We have a very large project we did in Eastern Europe. Over 5,000 radios installed on a metro line for subways, and they needed something to manage the entire solution. So we developed FM Monitor, and the FM Monitor allows you to go in and work with your design, help manage it, monitor it, update firmware. Every single radio comes with FM Quadro, so you can actually get live information on what's going on with the connectivity of your system, coverage, connectivity, who is it connecting to, where is it connecting to, and then Racer is a cloud-based solution that you can connect all the radios up to, configure the radios, and then you can download them and run them off the cloud if you want to, or you can reconnect them to go on the cloud and update firmware through that as well. So FM Monitor basically takes Racer and Quadro and all the information and rolls it into a dashboard to allow you to manage it. And then the product itself, very simple. It's a very small range of radios because we're software defined. We can give it different capabilities. So we have fixed solutions there on the left with integrated antennas, and then we have modular solutions on the right. And the modular doesn't have to be mobility. It can be fixed as well. The difference is it's a connectorized antenna. So the choice of the antenna is going to help you determine the distances and the throughput. The longest length we've done in an unlicensed spectrum is around 25 miles and delivering 40 megabits per second in that 25 miles. And do that in an unlicensed spectrum that's a fair amount. So that is basically it for the curb solution. I told them I can finish this fast because I want to get you guys into the exciting part. We're going to have a nice presentation here from BATS, and they're going to get into the meat of some real world applications and where they've taken the curb product and associated it with their antenna solutions and done some exciting things. So Philip, I'm going to pass it on to you and let you run the show here.
Well, thank you so much, Don and Roland. Thank you for allowing us to participate today. Again, my name's Phil Cramer. I'm the EVP of Sales and Marketing here at BATS. And we're thrilled to have recently joined the Cisco IoT program as a design-in partner, and working with Cisco to deliver our high capacity smart antenna systems powered with Cisco's industrial wireless products. And I can vouch with the number of deployments that we've done with the Curb radio that it is truly a superior product, and I appreciate working with you. And the BATS systems, when integrated with Cisco's industrial wireless products, whether it's the Curb backhaul or the cellular gateway solutions, will deliver ultra high capacity connectivity for both mobile, nomadic vehicles and vessels. Now, who is BATS? BATS is a technology company. We're a technology company, and our core AATS, automatic alignment tracking software, we have over 1 million lines of code. We're based in Indianapolis, Indiana. So when Don was referencing the IndyCar autonomous challenge that was here, that's literally about 6 miles down the road from us. Our company was originally, the idea for it, we were kind of a category creator in that our founders were Purdue University professors. I don't know if you know Purdue, but Purdue is a top 5 research institution here in the United States. And one of our founders was a professor there, the head of RF studies, and he was out as a summer job climbing towers and aligning dishes. And he said, there must be a better way than this manual aligning and tuning. And he did the first software that automatically aligned the dishes on those towers. And that was 16 years ago. We were spun out as an individual company 14 years ago. I joined 13 and a half years ago. Jeremy joined about 11 years ago. And since then, we have grown our business tremendously. And we're so thrilled to be partnered up with Cisco. And when you take those that innovative software that we have, and then what we do is we layer that over some innovative hardware solutions that allow you to take what normally would be fixed deployed links to be completely nomadic and mobile. So whether it's a 20-mile or a 40-mile link, we can do that on the high seas with great pitch and sway we enable you to take what normally um, maybe 10 years ago, you had to try and use an omni antenna and be good out to about 3 or 4 kilometers. We can now give you the same advantages of an omni in that it's 360-degree capability and apply all the same principles to a directional antenna. And we do that through our
Very
smart
cool.
antenna systems. Now, who have we done it for? The next slide, it just gives you an idea. We've worked with most all of the major integrated oil companies around the globe. And I'll go through a couple of deployment scenarios in how we actually help them be more efficient in the field, whether that's on land or at sea. You also will notice on here there's a number of cruise lines. We have a tremendous maritime business and defense business as well. But the oil and gas, the energy segment, as well now wind, is a very growing business segment for that. Now, how do we do that, and how do we apply this smart
Hey,
technology?
Phil,
Yes, sir.
before you keep going here, I want to go back to that last comment you made regarding wind. We had Mads Lindback on, as you know, yesterday to talk about Cisco and wind deployments, and a lot of what he's been working on is in the North Sea and around the UK area. And I know that you've done some work there. I don't think it's in your slides today, but I just wanted to call that out because we had Mads talk about wind yesterday. Actually, a lot of what we do from a connectivity perspective between the different turbines in those North Sea solutions is Curb and BATS wireless. So it might not be traditional oil and gas, but we've definitely seen some really solid results there. And the same things apply to the platforms and stuff that they're going to talk about today. But just know that we have an installed base there already in renewables.
Excellent. Good. Thanks for pointing that out, Roland. Roland, and please feel free to interject anything as I'm going along. As a matter of fact, no, we don't have a specific deployment scenario slide about that, but we have one better. We have a complete
Okay.
video that demonstrates
Right.
that deployment. Yes, we are working with Cisco, and the beautiful thing about it is we actually get to deploy in the same antenna solution your two of your leading wireless products, both the IR 1101 LTE modem, as well as the Curb FM 4500. And it's together in one antenna system that communicates via both LTE as well as 5 gigahertz unlicensed. And Jeremy's going to talk about that a little bit more in depth. But the first thing I just want to mention as we go across here, and again, all of our systems are powered by the same automatic aligning tracking software, whether it's our ATEX systems for zone 1 deployments in hazardous areas on like an FPSO or otherwise, all the way down to our agile and nimble fast solid state antenna systems. So starting there to the left, what is the FAST? The FAST is a very popular antenna system for us. It is frequency specific in 5 gig as well as in the NATO band all the way up through 4.9, so at 4.4 to 5.0. We have 2 versions of the FAST today. We have others, but it's for military use. And the FAST is a very innovative electronic beam steering antenna system. So you see there, it looks like an oversized Omni. What it is, there are 24 individual antenna elements inside of that little stick, if you will. And what we do is we, for each radio that we've integrated with, and we have a very solid integration with the Curb FM 4500 as well as the IR 1101. How we track is that we read the radio at the local side that's paired up to our antenna, Roland. And then what we do is we measure the signal quality of the connection via listening to the near side radio. And we integrate normally via SNMP or Telnet, some sort of a session where we can tell the quality, and our software through intelligent learning will continually peak that signal so that it's optimally connected at all times. And then to get in the area code, we can possibly use GPS data so that we automatically aim to the target and then track. And then we use predictive tracking algorithms to keep that signal constantly peaked. So it'd be as if you're standing out there on the deck and you are constantly aiming the antenna perfectly at the target at all times. That's what we give you the ability to do. And whether you do that with our fast system or our on-point system. Our on-point system is traditionally used where there's limited ranges of movement, just plus or minus 15 degrees of movement. And what we do is we even have the ability that thing is so precise, we have the ability to aim and stabilize 80 gigahertz links with sub 1 degree beam widths. That's the power of our software. Then we have quick deploy systems that for in the oil and gas sector are many times used out in land-based drilling and production. A number of these are deployed out in the Permian basin with some of our customers and your customers. And they pop up this quick deploy system, automatically scans, locates, and then locks on to the nearest sector base station or directional antenna. Then we have our BTS systems for much larger antennas, and then our DVM systems or dome systems. The bottom line is that we have both electromechanical as well as electronic beam steering antennas for various deployments. And paired with the curb radio and then the IR 1101 with our fast LTE system, we have an LTE version of that fast as well that we pair up with your IR 1101. But getting back to the curb and the FM 4500, some examples of uses offshore in that you'll have a connection between an FPSO and a drill ship or production platform. We automatically we automatically track back to the fixed point and constantly improve that signal at all times. You can go to the next one, Jeremy. The an example of that would be that we did for ExxonMobil down in Nigeria. It was a long shot, and it was actually over 40 kilometers. And they have two of our domes up on the FPSO, one located on two separate decks of the platform there, and they're aimed to a fixed antenna on land, and that deployment was down off the coast of Nigeria. And next slide there, Jeremy. Another common use deployment of our systems paired with your curb radio is satellite downlink and retransmit. So satellite obviously is very expensive. So if you can just have one downlink into an offshore field and then retransmit that data out, we can have the ability with our DVM systems to go 50 kilometers, provided that you have enough height, and provide excellent throughput while on the move. You can connect a whole field with just one satellite downlink and then rebroadcast that to all your moving assets in the field by using the curb radio paired with one of our smart antenna systems. So I'm just going through some of the common deployments that we see offshore in using the curb radio paired with our smart antenna systems. And then I think it might be the final one. Well, no, this is an example of that, where we can, we had a project with Canadian Natural Resources down in offshore the Ivory Coast. And there we had a point-to-point connection from on this offshore network, both platform to platform, and then the platform to the FPSO using your radios. And then another would be long-range communications. Again, sometimes you may have the ability to connect to a fiber link. And from that fiber link, you don't need a satellite downlink, but you're connected to fiber, whether that's the fiber ring over in the North Sea or in the Gulf of Mexico. Many times you'll be connected to a spur off of that fiber link and then retransmit that using our smart antenna systems and give you the long range backhaul communication that you need on the move. One example of that was for LLOG Resources. We did that. This is an 8-foot antenna system, or an 8-foot antenna. And that one now has been out there for 9.5 years operating in the Gulf. So next, I'm going to turn it over to Jeremy. Well, yes, this actually gets into the deployment that we want to show you the video about. And Jeremy's going to take it from here and talk about our smart antenna systems and a couple other land-based and offshore deployments. Thanks a lot, Roland.
Just to kind of jump in here. So the first here is on the vessel communications. So in this particular solution, this is actually very unique for a BATS and curb solution. The main reason why is because this is actually something that we're basing around the validated design that's currently in process with Cisco. So basically what this is doing is we're using the curb's ability to run point-to-multipoint networks, and we are actually using the FAST system to extend the range of that point-to-multipoint network. So basically what you'll typically see, at least what we usually see offshore, is maybe a 1 to 5 mile kind of link with an Omni. With using a BAT system, you're well beyond 10. So we usually like to tell people around 16 kilometers plus when you're running a fast system. And so in these particular applications, this is actually a specific use case that we can kind of get into as well. Typically what they'll do, this is an oil and gas customer that we had. They actually use these as support vessels. And so they'll actually run these specific systems out in the field to provide connectivity for both crew comfort and for communications. And they're connecting back to shore. So they'll use that either with the DVM, and the DVM will just extend your range. So you're basically doubling that range over the fast, or you'll run with the fast. And just as an example, I know I talked to Don a little bit, and he wanted to get an example of kind of the size of the fast. You can see right here, it's not that big. It's a very small unit. And it's something that can fit on the back of a vehicle or on a vessel itself. So we do have a video here, and let me see if we can get this going. And let me know if the audio coming through okay.
BATS smart antenna systems, when integrated with Cisco's industrial wireless products, including its curb backhaul and cellular gateway solutions, will deliver ultra-high capacity connectivity for both mobile and nomadic vehicles and vessels. Ideal for the unique demands of onshore and offshore operations in the energy, shipping, public transport, and defense markets, the integrated solutions will provide the flexibility needed for dynamic and adaptive networks. The smart antenna system features Cisco's industrial wireless solutions and will deliver a wealth of cutting-edge wireless communications and data opportunities for IoT sensing and monitoring applications, autonomous and augmented control applications, and intelligent multi-network roaming solutions. The fast 2x4G system, for example, features Cisco's Curb FM 4500 backhaul radio, IR1101 5G router, and IE 3300 network switch, giving operators the ability to run independent 5 GHz mesh and LTE communications channels in one system. The 2x4G solution enables intelligent, public-private multi-network communications and can help bridge the gap for operators in shore-to-field or shore-to-rig applications. Every day, whether onshore, offshore, or in flight, BATS technology is proven in some of the harshest conditions on Earth, providing organizations access to their critical communications.
So, so the video basically covered what we're currently doing, and will actually eventually be a validated design for multi-network communications, specifically in kind of those field deployments for wind specifically. And typically what this is it's both the Cisco Curb backhaul radio as well as the IR1101 LTE router. Those are actually combined inside of a single smart antenna. And then that allows us to basically do that multi-network communication. So as you can see kind of in this graphic here, you've got your, this will represent more of your LTE base station side of things. And then on the rig out here, or it could be, in a wind farm support structure or something like that, you'll have your curb network. And then basically what you're able to do, it's kind of interesting. So you can start off with LTE communications, either public or private. And then as you get further out to sea, you can either connect to a private LTE network, or you can connect to a curb-based network that allows you to kind of do that handoff. The interesting thing about that is you also get the benefits of not only the handover, but also you can start adding in some bonding or things like that to kind of increase your throughput as you're going throughout your network. Part of the reason why this is particularly attractive to a lot of offshore operators, especially in the wind area, is because they'll usually run fiber out to that field, but they don't really have anything that'll handle communications that are closer to shore. And so this gives them a couple things that they can use them for. The first thing is they can do the LTE communications with a private network on shore, and they can also then dynamically switch over to a public LTE network on shore. And then as they get further out to sea, they can then switch over to a private Wi-Fi or mesh or backhaul-based network using the curb radio. So it's very beneficial in the transitional stage from shore to sea, and as you're going out to start monitoring and doing maintenance work in the field, because it will allow you a little bit more autonomy in terms of your communications. One of the interesting use cases that came up as a result of us working with our customer on this particular application is the ability for them to blueprint this in one region and then put it in every other region where they're going to have a wind farm set up. And the benefit for that is immense. So now they have one, defined, validated solution. They can roll it out across the globe. It doesn't matter if it's a private LTE network or a public LTE network. It's just a matter of, switching out whatever network it's going to be, and you can do that dynamically. And you can actually do that with the, the IoT solutions that are available. Not only that, with the curb solution as a part of their network, a lot of these wind operators are already installing those on top of their wind turbines. And that's actually what's happening in one of these projects with us right now. So they're getting a lot of flexibility in their communications because they can link up every single one of the wind terminals, as well as they can link that back up to the vessel. So It's a very exciting application that's coming on now for us. And it's got some immense capability for its flexibility, not just with wind, but also with oil and gas. As you can, one of the applications we typically run into will be a supply vessel that's going between the shore side and out to an oil rig. It's going to be no different in terms of its operation. So I'm going to jump into some of the land-based drilling applications that we typically also work with, because we did want to get into some of the land-based stuff and not just do all offshore. And these are going to be, you'll see kind of a theme here. A lot of the time when individuals want to engage with BATS for a land-based opportunity, it's going to be one of two things. Either one, it's going to be network extension. So they're so far out, they need to get a connection in somehow. And so we've done these from some pretty decent distances. And then the second thing is going to be in field automation and control. So if they want to do any kind of monitoring or any kind of control, they'll need to put a lot of data on that link, and that's something that they may not be able to do with their traditional IoT networks. And so that's when they'll bring in like a curb solution to provide that backhaul, and that offloads all of that camera and IP data. So typically in this use case, for example, we'll see, out in the middle of a field somewhere, they'll either run the curb backhaul radio as a backhaul link to a trailer, and that'll give them, a pipe out to their company-wide intranet, and then they'll actually be able to connect back to all of their rigs as well, so they can then see they can monitor health, and then they can also remotely do shutdowns, things like that, so they can go and do repairs. So that's one big application. And then the second way that they use these is they'll typically run the same trailer, but they'll use it on LTE. So you've got flexibility there. And we do have combined solutions where you can run both of those, again, with the 1101 and with the curb. Here's an example. This is going to be more, it's nomadic command communications. This was more in a mining application, but they were doing some autonomous control or some remote control of digger vessels, but you can kind of see, or digger vehicles, but you can see kind of how these are used. So they kind of go out, they'll deploy these out in the field in the middle of nowhere, basically. They'll use these as their backhaul link. And then they'll basically offload a lot of that video data so they can do command and control from that trailer. Another one of these applications, and this is one that we get, we typically get a lot of traction around, is quick deploy refinery turnaround. So this may be, customers that we'll typically work with will have a quick deploy kit, and they'll have this, pelicanized, everything's in that kit. They'll go out to a site that's, undergoing a turnaround, and they can simply go out, deploy this thing. It's usually deployed on a tripod, and they'll actually just connect up to either their wireless backhaul link, or they'll run LTE to an area and offshoot that to wireless backhaul. And then what they'll do from there is they'll set up their own wireless LAN infrastructure in that area, so they can then run any of the other devices that they need to for the refinery turnaround. So, and then one of the examples of this particular is we do this with ExxonMobil. We've done this a number of times with them. One of the examples was in Torrance, California. So this was basically a quick deploy on a trailer. We did a shot right off of one of the storage containers to get around that area so they could actually do that turnaround work. And with that, I think that's just about it.
Thank you for joining us for this session. If you found value in this session, please like and subscribe and click on the next video. Take care.